With us again is Dr. Michal Daněk. He's been on stage before, and he has been key account manager for Central Europe at BGS since 2005. Graduate plastics engineer, he obtained a PhD in 2014 on the influence of radiation on polymer properties. So the floor is yours about critical infrastructure. Please, Michal.
Thank you very much, Mr. Jorsal, for the second time today in section critical infrastructure. Critical infrastructure is the term that has been mentioned quite often recently in the context of the current energy crisis. Critical infrastructure is not just energy or gas sector that are most troubling us at the moment, but it is an asset or system which is essential for the maintenance of vital societal functions. I hope that my presentation will be not so critical today and you will enjoy. I would like to today introduce the important components that are integral to critical infrastructure and that they are positively and successfully influenced by radiation technology. I will also briefly introduce the advantages and benefits of radiation crosslinking for these components. In the second part of the presentation, will our dear guest, Peter Jorsal from company Kingspan, give you a detailed view to shrink products and their benefits for critical infrastructure with the contribution of the radiation crosslinking. If I see this picture generating question in my mind, what critical infrastructure means for our daily lives? What global impact it has on our lives when something in the critical infrastructure and their elements does not work properly? I think many of us have an answer to this question and have also personal experiences on the impact on our daily lives. Radiation crosslinking technology helps meet most of the demanding requirements for long-term durability, safety and security of many components. Let me introduce these important components that are integral to critical infrastructure and are positively affected by radiation crosslinking technology. One of the very important components of critical infrastructure which connect, lead, transmit, heat and so on are cables and wires. Cables and wires are one of the longest and most successful irradiated application. The first commercial radiation treatment began in 1957 in the USA. Mainly used material for isolation are here PVC, polyethylene, or thermoplastic elastomers. The benefits of radiation crosslinking for cables and wires are, for example, increased resistance against heat, improved aging behavior, or better resistant to chemicals. Cables and wires are usually delivered as on the drums, as discussed also today. By crosslinking process are the drums rewounded and again wounded under the beam scanner. Another very important part of critical infrastructure where has been radiation crosslinking used more than 30 years are various electrical components. With these products, we come contact it every day, and they are all around us, and we cannot imagine our daily lives without their seamless and safe functionality, especially switches, various relays, connectors, overvoltage protection, and so on and so on. Mainly used material for these components are polyamides and PBT. The benefits of the radiation crosslinking brings to these components, for example, improved resistance against the heat and flammability, and short-term thermal load over 400 degrees C. Electric components are usually irradiated as a bulk goods in paper boxes or in plastic containers. Plastic pipes, tubes and rods are also an integral part of our daily lives. for example, drink or hot water supply, and so on, and belongs to the group of important critical infrastructure components too. Mainly used material for these products are here polyethylenes. Added value of radiation crosslinking for plastic pipes, tubes, and rods are, for example, high durability over time or improved creep behavior, which brings them long-like security more over 50 years. Plastic pipes and tubes are usually irradiated like the cables, mean on the drums. The rods are irradiated like the bulk goods, mainly in our Bruxar facility on biggest conveyor we have with length of 12 meters. These rods are often used in gas distribution. Last but not least important components from critical infrastructure which we crosslink are shrink products. Shrink products belong similar to the cables and wires also to one of the longest and most successfully irradiated applications. I hope that Peter Jorsal is connected and hear us, and Peter will present you the details for these products. Peter, you have your floor.
Thank you. And I just want to be sure that you can see my screen.
Yeah, we can.
Super. So thank you. My name is Peter Jorsal, and I am a product and academy manager in the company Kingspan Logstor. And we are producer of pre-insulated pipe systems for applications, district heating and district cooling, but also for industrial and oil and gas applications. Pre-insulated pipes for district heating and district cooling is critical infrastructure, and my presentation will be about cross-linked casing joints for the pre-insulated pipe systems. Just first briefly to give you an overview about what is pre-insulated pipe system. So pre-insulated pipe systems are mainly buried pipe systems, so they will be in the ground. Estimated service lifetime for these pre-insulated pipe systems is more than 50 years. Pre-insulated pipes are 12 or 16 meter long, and together with pre-insulated bends, pre-insulated tees, pre-insulated valves, they will be connected together. And every time we connect pipes and fittings together, we need a casing joint. And the casing joint shall make it tight where you connect it, and it shall be tight for the entire lifetime of more than 50 years. The most sold casing joint we have is a cross-linked shrinkable sealed joint where we have an annual sales of more than 500 pieces every year. So just a short overview about what is actually pre-insulated pipes for district heating. The cross-linked joints have a lot of very strong features that create very strong values for the customers. And our customers is mainly the energy companies that are the owners of the pre-insulated pipe systems in the ground. I will, in 2 short videos later in my presentation, show you the features. But just to highlight a couple of the features you see on this slide is that when we have cross-linked materials, it's not sensitive to overheating. So even if the material is overheating, it will keep the shrink force. And another very strong feature is that when we have cross-linked material and we transport our casing joints to countries in the south part of Europe or in the Middle East, we will not have any risk of casing joints that will start to pre-shrink before installed on the pre-insulated pipes. And that could be the case if we use non-cross-linked casing joints. This is just a short overview about the different type of crossing joints that we have. I will not get into details of each of them, but just to tell you, we have straight cross-linked casing joints. We have casing joints that are used as bends, and we have casing joints that are used as tees. shortly about the production process. The production of a cross-linked casing joint starts with blow molding a piece of PE like you can see on the right part of this slide. So this is a piece of PE blow molded in a blow molding process, and at this point it's not cross-linked, it's pure PE. Then we prepare these samples to be cross-linked, and we pack it in boxes and send it for the cross-linking, where it will be cross-linked by high energy radiation. When the cross-linking is finished, we will get it back in the boxes, and we will be ready to produce the casing joints that we will send to our customers. So when we receive the cross-linked samples, then we will heat the samples up till 140 degrees, so the material will get in a kind of a rubbery state. The shrinkable parts are expanded, like you can see on the picture to the left, either on the whole casing joint or at the ends, but it will be expanded where it's intended to shrink when we, during the installation later on the project, will heat it. The expanded areas will keep its shape until it's heated again. So it will be cool and then it will keep its shape. The crosslink joint has a memory effect. So when heated, the casing joint will try to shrink down to their original surface. And when installed on a pre-insulated pipe, it will not be able to shrink down to the original surface, because before that will happen, it will meet the casing of the pre-insulated pipe. And by having the shrink force, it will make a shrink force, a force on the sealing that will be in between the casing joint and the pre-insulated pipe. And that is what will secure the tightness of the casing joint over the entire lifetime of more than 50 years. Then I have 2 videos that actually, better than words, explain the features of the cross-linked casing joints. The first video is a video where we will heat up a place on the cross-linked material, and we will overheat it so that it becomes very, very soft. Then we will put air pressure to the casing joint, and it will start to expand in this area where it's very hot and very soft. And we will expand it to the extreme, so the material gets extremely thin, like paper. Then we will cool it down. And when it's cooled down, we will start to heat it up again. And then the material will try to get back to the original shape. And that is what happens. After heating it for some time, it will get back to the original shape. And then, just to prove that it is tight and it's not broken, we will put pressure on again. And we can actually do this exercise again and again. So really, it shows the feature of the crosslink joint being able to expand it very much, and that it is not really sensitive to overheating. It will remain its shrink force and will not break the material. The next video that I will show is where I will compare a test on a test piece of polyethylene, so non-cross-linked polyethylene, with a same test kind of test piece, same geometry of the test piece, but a test piece of cross-linked material. So the first test piece that we will test is a non-cross-linked polyethylene material. So we have a test piece with a weight in the end, and we start to heat it. And this is non-cross-linked material. And after heating it for some time, it will break. Then we do the same test, but now it's with cross-linked material. And the geometry of the test piece is exactly the same. After heating it for some time, it shows it will not break. And we continue heating it, and we stretch the material. Then we let the material cool down, and we start to heat it again. And the shrink force is so big that it actually is able to lift the weight. and it will try to get back to the original surface. So the material is not breaking, it keeps the shrink force, and that is really the essential part of cross-linked shrinkable casing joints, that they keep the shrink force and they don't break when overheated. And that is essential for having the long lifetime of the systems. Casing joints for pre-insulated district heating pipes shall be tested according to European standards. And all our casing joints shall be tested to have a so-called type test of the joint. So we need to fulfill all the requirements in the standard, and that is proven by tests. One of the tests that we are doing on shrinkable joints is a so-called sandbox test. So we put a piece of pipe where we have installed a casing joint in a sandbox. So we actually try kind of simulate a buried pipe system. And then we start to move this piece of pipe 75 millimeter to the one side, back again to the middle, 75 millimeter to the other pipe, and back to the middle. And that shall happen 100 times, so it shall be repeated 100 times. After that test, it will be tested if the joint is still tight. And to be able to prove that we are conform to the requirement in the standard, the joint shall still be tight. And it is. So it is a very tough test, but with the crosslink joints, there's no issue in complying with the requirement in this test. If we look to the future of pre-insulated pipe systems for district heating and district cooling, and thereby also the need for cross-linked casing joints for these critical infrastructures, then district heating and district cooling, they really have an important role in securing the highest possible energy efficient heating up or cooling down of buildings with the lowest possible CO2 emission. And really the focus today in the world is reducing the CO2 emission. Exactly. District heating and district cooling has a very important key towards this green transition, because district heating and district cooling can use excess heat. It can use all kinds of heat produced from non-fossil fuels, from biomaterials, from wind, from solar. So it's really important in the green transition where we don't have the dependency on fossil fuels. So the trend we already see now is that the need for pre-insulated pipe systems for district heating and district cooling in the future will increase in the coming years. And that trend really has started. So if we look at what will be the effect on the requirement for cross-link joints, then the requirement of cross-link joints for the pre-insulated pipe systems will for sure increase in the coming years. So thank you. That was my part of the presentation.
Thank you very much, Peter, and thank you very much, Michal, for this presentation. And ladies and gentlemen, it might appear to one or the other from you that it might even be frightening how much dependent we are on critical infrastructures. And obviously, radiation crosslinking plays a dominant role in the whole play. And even the first slide that you presented, Michal, was very telling, I would say. But we were also discussing the availability, of materials, and capacities of irradiation in this field. How secure are we on that side? What would you say?
I think we are totally secured. Mainly our customers are secured because this cross-linking is occurred on our two biggest machines. This means our S10 accelerator and B10 accelerator, where the capacity it's like sufficient. Yeah. And we are cooperating with Logstor and Kingspan very intensively to optimize the process of the cross-linking, in a direction of packaging, to improving and to speed the process. And I think we are in a very good way, and the people in Logstor making very good job. And I really, Peter, appreciate it that we really increase the capacity, secure for them, good also for us. Means the treatment is easier because we can use the automatic palletizing system in SAL instead of the manual handling, which is of course in disposal at B10 accelerator, but the way is to use automatic treatment and a fully automatic line, which we are having in our SAL facility.
Peter, one comprehensive question for you, because you mentioned in the sustainability part, of course, we are all looking into reducing our carbon footprint. And to rephrase this, you said through those pipes, they are kind of bulletproof. You can send anything, any carrier of energy through it or heating through it. Is that true?
Basically, it's true. There's you can have a district heating media, but we also have pipe systems for industrial processes. So I mean, it's all a question about the service pipe itself, and we can pre-inflate any kind of service pipe. For district heating, it's very standardized. It's normal carbon steel, but for industry, we have many different type of service pipes. So I mean, there's no limitation, I think, on what can be the media, and we can have pipe systems actually we have transport of also liquefied natural gas, so to very, very cold temperatures, and we also have pipe systems for steam for very, very high temperatures. So everything in between, we actually have as part of our applications.
Yeah, absolutely fascinating. And of course, this is exactly what we're looking into for the energetic distribution of the future. Peter, there's one concrete question here from our listeners. How long did it take you to integrate your processes with BGS and until it was routine?
Probably, Michal, you can tell that better than I can. I'm not familiar to that, so probably you can give a better answer to that question.
If we look at it generally, I think we integrate this. If I will talk about this optimization of packaging, let's say in 3 months, yeah. But now, including the optimization, let's say in half year, we really optimize the system to have the main volumes in a very good line for this automatic packaging. But it's a very good job from the people from Oxtor.
Mm-hmm. So also a question more or less to both of you. How do you think demand will develop all over the world due to the development of renewable energies? We hinted this a little bit, Peter. Maybe you make your first entry there.
Yeah, but it will for sure develop because by having district heating as a key to use excess heat of all temperatures, no matter from where they are coming, then we can use the excess heat, and then we can distribute this excess heat to heat up houses, or we can even through heat pumps use it for cooling down houses. So the key is using the excess heat that is available everywhere, and then have a pipe system that will be a pipe system with a long service life, distributing the heat to the consumers.
Yeah, thank you, Michal. A practical question: what is the maximum size of the components you can irradiate?
Yeah, we are limited with the space between the scanner and the conveyor. That means the maximum diameter we are allowed to do, it's about 650 millimeters diameter.
Right. So, 2 perspective questions, if I may. Peter, first of all, I mean, we're talking about reusing, upcycling, recycling. You mentioned we have 50 plus years for your pipes, but eventually 50 years pass. Then you dig those pipes out. Then you have the irradiated crosslink materials in there.
Yeah.
What are you going to do in the sense of recycling, in the sense of reusing?
It's a good question. Actually, we have a vision that we shall. We have a green vision, and it's kind of two-parted. So we shall be able to. One part is that we shall be able to produce all our materials from recycled material, and we have started that travel already. Another part of the vision is that at end of lifetime, all the materials that are in the ground shall be recyclable. And you can say, to my knowledge, on the crosslink materials, we might still have a challenge how to recycle crosslink material, and we are working on that because we need to solve that. Yeah. But here we still have a challenge if you compare that to non-crosslink material, because non-crosslink material you can recycle.
Right.
I'm pretty sure that there will be solutions for recycling crosslink material as well.
Yeah. And you have some time left to develop those mechanisms.
Yes.
Most definitely.
But we have to develop
you
it.
wanted to jump in.
Yeah. I would like to add that I would like to just tell that really this is the topic, the recycling. I think behind this section we will hear something from the using of cross-linked polymers.
Right.
But from my experience, I could confirm that the cross-linking polyolefins are already investigated and exists solution for successfully using and recycling of the cross-linked polyolefins.
Yeah, right. So, and also in a nutshell, we're discussing two elements. One element is durability, and 50 plus years, we're hearing from Peter. And so there's a lot of time to think those effects over in general. I have an additional question here, maybe also to both of you. Can you explain the memory effect in more detail? Is it limited to certain temperatures?
I would like to thank you, Peter, for your very, I think, nice and interesting presentation, mainly 2 videos, which really explain the phenomena of this memory effect. Which
looks like a balloon at points. Was fascinating.
Important to say, and this is really, let's say, essential, that this kind of technology is not possible without cross-linking.
Yeah.
And that is for me something like magic, because really you are not able to achieve this kind of phenomena, means memory effect, without cross-linking.
Would you add up to this, Peter? No, I fully agree. I think the videos really show what are the features and what is possible with crosslink material, and you really see that it finds back to the original shape just by heating. Even you are very close to having a state where it's kind of. I really fear that it's exploding every time I see this test, but it's not. but you can shrink it down and it will find the original shape, and that is really the memory effect. Thank you. A technical question from our audience: can electronic components be irradiated with gamma and E-beam?
This is a very good question. What kind of electronics components that need to be specified? But generally, I have to say that the radiation have a bad influence of the electronic. That means if should be the electronic inside, it's better to really cross-link the housing and so on without the electronic. Really, radiation damaged all electronics parts.
Yeah. Okay. I would like to close this session with asking the visionaries in you both a little bit, because Michal, you pointed out in a much broader, holistic way which critical infrastructures are, at the end of the day, really affected. And I would love you to explore a little bit and explain a little bit where you would see additional fields for radiation cross-linking in critical infrastructures. You pointed out the status quo and what is in the pipeline right now, but in the bigger picture, what is going to happen eventually?
It will be connected everything with what already was discussed in previous sessions, have to do with the CO2 reduction.
Right.
That means we will go the way of the E-weld. That means high voltage, means generate what I said in presentation, high voltage cables, connectors, and so on.
Right.
And then we will, of course, going to for central heating, district heating, which is offering this solution, company Kingspan. This means this all will be going this green world. I think it's good for us, for our planet, and there will be the potential and growing up of course, using of the radiation technology.
Yeah, of course, Peter, you are in a country where I remember, I guess Copenhagen was one of the first cities to ban cars out of inner city districts. And we discussed previously on this conference here the effects of urbanism, with climate change, fight, and all that's connected with it. You contribute big time with the pipes that are multi-compatible, you may say. But what else do you see on the horizon, also asked as a visionary?
So in respect of pipe systems for...
Not only pipe systems, even beyond.
Yeah, okay. But I mean, for cities, the challenge is really to be CO2 neutral. And being CO2 neutral, the key to that is to look at how do they heat up or how do they cool down their houses. Same for industries. How can they become CO2 neutral? So I think energy somehow is for me the most important key to this CO2 neutral future.
Yeah. I promised you it was the last question, but I have even one more. Does a material such as PA12 have to be especially prepared for radiation crosslinking?
Yes. Polyamide 12 must be modified. I think it was part of the presentation of Mr. Stenglin. Must be modified through crosslinking agent to be crosslinkable.
Yeah, okay. So thank you a lot for this session, Peter and Michal. It was a pleasure meeting you and getting your insight there. I will switch to German now and Michal, stay for a second, weil wir haben gefragt, natürlich bei der interaktiven Frage über Slido in der letzten Runde, ein Blick auf die Potenziale der Strahlenvernetzung, und da waren wir ja gerade mittendrin. Ja. Welche sehen Sie? Bevor wir die Ergebnisse einblenden, welche sehen Sie denn?
Wo die Potenziale sind?
Genau.
Das wird zum Beispiel genau, was haben wir heute gesehen? Für mich die Potenziale unglaubliche, weil der Phänomen als dieser Memory-Effekt ist einfach amazing.
Ja.
Das heißt, ich sehe definitiv Schrumpfschläuche, Schrumpfprodukte als in Schrumpfen. Weiter, klar, haben wir gesehen Kabel. Ja, da geht sonst das 1957 in den USA 57
ging das schon los,
hat das in den USA begonnen. Ja. Die Story geht weiter und wird sich entwickeln weiter. Das heißt, dazu verbundene elektrische Komponenten. Das heißt, muss ich sagen, ich habe keine Angst über Zukunft von Strahlenvernetzung und keine Angst über Zukunft von unsere gute Firma BGS.
Und jetzt wollen wir mal gucken, wie unsere Teilnehmerinnen und Teilnehmer, wie Sie das gesehen haben, und lösen mal auf. Ein Blick auf die Potenziale der Strahlenvernetzung. Welche sehen Sie? Eigenschaftsverbesserungen, darüber haben wir gerade gesprochen, 61% absoluter Spitzenreiter, und es bewegen sich die Säulen so ein kleines bisschen noch Substitution von Materialien, 13% Materialressourceneinsparung, 13% neue Anwendungen, auch 13% und keine davon 0%. Also Sie alle haben Vertrauen, dass sich da einiges tun wird bei der Strahlenvernetzung. Herzlichen Dank für die Teilnahme.